From our last lecture, we have learned that the trig functions of an angle correspond to a given coordinate p, x, y is given by this definition here. Sine theta equals to y over r, cosine theta is x over r, tangent theta equals to y over x. And then we can find the value for secant and cosecant and cotangent. Actually, from this point, we can already compute additional, the trig values of additional special angles, like for example, 0 degrees, 180 degrees, 90 degrees, and 270 degrees. Let's say, for example, if we want to know the value of sine, cosine, tangent for 0 degree. So the corresponding angles for, the corresponding coordinates for 0 degree, will be, 0 degree will be here, right? Now that corresponds to the coordinate r, 0 if this were r. Is it right? Okay, so for 0 degree, or you can also say for 0 radian, sine 0 degree will be y over r. The y is 0 over r, so this is 0. Cosine 0 degree will be x over r, that's 1. And tangent 0 degrees is 0 over r. The y over the x of that coordinate, that's still 0. Okay. Now we can do the same thing for our 90 degrees. The coordinate correspond to that angle is 0, r. 180 degrees, the coordinate correspond to that angle is negative r, 0. And for 270 degrees, the coordinate correspond to that angle is 0, negative r. Now, instead of going through this route, I will go on with a unit circle approach. Now, what is unit circle approach? On unit circle approach, we will set the r, we let the r to be equals to 1. So this circle that we have here, the circle becomes unit circle. Okay, now unit circle is another approach that supplement our right triangle approach, and it's actually provide a very good flavor into trigonometry. Now, if we look again into that circle, what happened is then, because the r becomes 1, then this guy here now becomes 1, right? Let me change it to 1. The r there becomes 1, okay? So what happened in our formula also, because the r equals to 1, then sine theta basically equals to y, cosine theta basically equals x, and tangent theta stays the same, y over r, y over x. Now, because of these, especially this last two here, then I can update my P now. The coordinate correspond to that angle is as long as my radius is 1. Then my coordinate P may be expressed as x, which is known to be cosine theta, and the y, which is known to be sine theta. Okay. So for example, if I have for example, the coordinate here is it's given to us that it's a unit circle, and then the coordinate here is the theta, the angle theta, the central angle is theta. Then we know right away that the coordinate here is cosine theta and sine theta. Okay, so if we know the central angle in standard position, then the coordinate on the unit circle correspond to that angle is cosine theta, sine theta. Now, so for example, if I go on further, saying that this theta is actually 60 degrees. If I change this theta here, becomes 60 degrees, then the value here becomes cosine 60 degrees and sine 60 degrees. Okay, and we know the coordinate P therefore is cosine 60 degrees 1/2, sine 60 degrees radical 3 over 2. Okay. Now, to go on further, then we can have this. So you see that we deal a lot with unit circle now. Okay, let me erase some things first. I want to summarize what we can do. Oops. What am I doing? I want to summarize what we can do using that unit circle approach. And that's it. That is that we can find the value of special angles, additional special angles, actually quite fast. Okay, now, as we have seen earlier, if this is unit circle, then the coordinate here is 1, 0. The coordinate here is 0, 1. The coordinate here is -1, 0. And the coordinate here is 0, -1. Okay, for this one, I need you to follow me in sketching. Now, then the angle equals to 0 degrees or 0 radian, that corresponds to coordinate 1, 0. This coordinate here, okay, on a unit circle. In a unit circle. Now, because we know the coordinate for that angle, then we see right away that sine 0 degree is the y component, cosine 0 degree is the x component, and tangent 0 degree will be y over x, just like before, which is 0. Okay, now of course I need you to memorize, from now on I need you to memorize the sine, cosine, tangent, and consequently secant, cosecant, cotangent values of 0 degrees, 90 degrees later on, 180 degrees, and 270 degrees. But instead of writing them for each angles, I rather you to have this basic understanding that uh, for the corresponding angles, if you can find the coordinate on the unit circle, then the sine of that angle is the y component. The sine of that angle is the y component. Okay, and then the cosine of that angle is the x component. Okay, that's what I want you to have, and then the memorization will be a lot easier. For example, suppose I go on for theta equals to 90 degrees, okay, or pi over 2 in radian. Now that corresponds to the coordinate 0, 1, right? This angle here, if this is 90 degrees, okay, or pi over 2. Now, because that's 90 degrees and the radius is 1, then we know right away that sine 90 degrees is the y component. The y component is 1, right? Okay, can you do the cosine and tangent? So cosine 90 degrees is the x component, and tangent 90 degrees is the y over x, or sine over cosine, that is undefined. Okay, now how about when theta equals to 180 degrees, or in radian that's pi? Then the coordinate corresponds to that is coordinate 1, -1, 0. Then from there right away we see that sine 180 degrees equals to 0, or sine 180 degrees is -1, and tangent 180 degrees is 0 over -1, which is 0. So instead of memorizing, again, instead of memorizing the values, try to memorize the coordinates on the unit circle that correspond to that angle, and then you can get these values really fast. Okay, a lot faster. Suppose if the angle is 270 degrees, 270 degrees, which is 3 pi over 2. Now then you see, oh, what is the coordinate on the unit circle correspond to that angle? Theta equals 270 degrees, which is 3 pi over 2, corresponds to coordinate 0, -1. So sine 270 degrees is negative. Cosine 270 degrees is 0. And tangent 270 degrees is undefined. Okay. Let me give you some time if you want to copy that down. Okay, I think you need to copy that down, but when you memorize, don't memorize from the what you copy, but memorize from the unit circle. Okay, what it looks like on the unit circle.
Professor, do you mind
Yes.
scrolling up a little bit so I can get the bottom?
Oh yeah, sure.
Thank you.
Mhm. Okay. Let's continue. Let's continue. I'm about to show you one paper. Let's see where did I. Well, I will put it on. I will put it on notes. Give me a second. I said this to my other Precalculus class. I wonder if I say that to you too, saying that I say this to them. I say that in this course, especially for the trigonometry part, you need to memorize a lot of pictures. You know, do you see this with you? Do you see this, by the way? This picture?
Yeah, we see it.
Yeah, okay. Now, I said this to my other class that I know some students like to say, oh, Thomas, I'm an audiovisual person, you know, I have that audiovisual learning style. Okay. But from the same person who say that, that person also say, do I have to memorize this? Do I have to memorize this? This is what I want to say. Okay. While I understand that it is true, a lot of people, including me actually, is an audiovisual learner. Okay. But that statement comes with a consequence. What kind of consequence is that? Okay. That the consequence is it means you are someone who can memorize figure. You are someone who can memorize picture. Right? Okay. So you can look at that picture and then understand what that picture is saying. That's audiovisual learner. Okay. You can't say that you are a visual learner, but you cannot memorize anything visually. No, it's contradiction. Okay. Now, so I'm not saying that no, you are not a visual learner. No, actually, regardless you are a visual learner or not, you need to train yourself for that. Okay. So here's the thing, though. Here's the thing. I say that for to actually encourage you. If you say that you are a visual learner, then it's supposed to be your strong point here that you memorize things from the picture. Okay. Now, on the other hand, if you are not a visual learner, then you know that you need to learn it this way anyway. Okay. Once you go to university, you will not be separated into different courses. And when they say, okay, for this section here, the teacher is Mr. A, and he will teach using this learning style. And teacher B will teach you using visual style. And teacher C using non-visual style. No, there's no such thing in university. There's no such thing at SMC. Okay. In other words, when we say that you're a student, you're a learner, you learn any learning style anyway. Okay. So even if you are not a visual learner, okay, I would like you to know that you need to learn it that way anyway. I mean, no, don't get discouraged though, saying that, Thomas, that's against what I usually do. Well, if you already get used to it, you don't have much to learn. Okay, when we say we learn, we actually have an open mind to learn another style of learning. Okay. Now, here's the thing though. I try to bring you to a situation where we try to memorize the trig value, at least the sine and cosine first, of special angles in the unit circle. We already learned the trig values of special angles in the first quadrant, the ones that set us that corresponds to 30 degrees. Oops, sorry. Corresponds to 30. Let me use different calculator. Corresponds to 30 degrees here, 45 degrees, and 65 degrees. Now later on, after class, you know, I have my lecture notes I usually post, and below that lecture notes, I will give you this worksheet also. Try to print it out, or at least download it to your phone or your computer, and practice yourself in visualizing the coordinates. Okay, because once you have the coordinates, give me a second. Once you have the coordinates here, you actually know the sine and cosine of that angle. You see, right? You see what I mean? Okay, so for example, for 30 degrees, we already know what's the value. What is the cosine of 30 degrees? Cosine of 30 degrees is square root of 3 over 2. And the sine of 30 degrees is 1/2. Is it right?
Yes.
Now, we go on with the cosine of 45 degrees. We know that square root of 2 over 2 and square root of 2 over 2 for sine and also for cosine. Oh, sorry, it's not 65 degrees, it's 60 degrees here. I write it wrong. 60 degrees here. Now then, what is the x component of the coordinate correspond to 60 degrees on the unit circle? So the x component will be cosine 60, right? Now cosine 60 will be 1/2, and sine 60, the y component, will be square root of 3 over 2. Okay. By the way, the radian measure for 30 degrees is pi over 6. Radian measure for 45 degrees is pi over 4. And radian measure of 60 degrees pi over 3. Okay, now I told you to memorize this on Monday, so I assume you memorize that also here. Okay, now what we have learned just now is what happens if we have the other special angles on the quadrantal angles, 0 degrees or 0 radian. The coordinate correspond to that is 1, 0, which means cosine 0 is 1, sine 0 is 0. Okay, for 90 degrees or pi over 2 in radian, the coordinate correspond to that on the unit circle is 0, 1. Now that tells us that the cosine 90 degrees is 0, sine 90 degrees is 1. Okay. Furthermore, for 180 degrees, that's pi in radian. The coordinate corresponds to that angle on the unit circle is -1, 0, which means cosine pi is from this picture, what will cosine pi be? Cosine pi is the x component of the coordinate correspond to that angle. Okay,
So -1.
so cosine pi is -1, that's right. And sine pi will be 0. Okay, now let me do the last one here. For 270 degrees, the radian is 3 pi over 2. Coordinate correspond to that is 0, -1. Okay, try to follow me in writing as much as possible. Okay, but if you can't, don't worry too much, because I provide you the notes anyway at the end of the lecture. Okay, I will post it on the discussion board. Okay, and I will also give you the blank sheet for the paperwork, not paperwork, I'm sorry, the worksheet for this unit circle here. And this one is 360 degrees coincide coterminal with that 0 degree, and the radian measure is 2 pi. Okay, now here's the thing though. I will suddenly do the certain extension. I will first introduce you to a new terminology called reference angle. Reference angle. The reference angle, for theta in standard position is denoted theta hat and defined by, and I put the comma here, and is defined by the acute angle from the terminal side. I think I should say the acute angle between the terminal side to x-axis. The reference angle for angle theta is, we denote it by theta hat, is defined by acute angle between the terminal side and x-axis. Now, we are not talking about the angle between the terminal side and positive x-axis. No, not that one. Okay, that one is angle in standard position. No, reference angle is the angle from the terminal side, to x-axis. So let's say, suppose I have this angle theta here. Let's say this is angle theta. Okay, now then the reference angle will be from that terminal side to the closest x-axis. Okay. Now, consequently, then theta hat will always be an acute angle, at most 90 degrees. Okay, at most 90 degrees. But it's supposed to be an acute angle. Suppose I have, for example, an angle here. Let's have an angle there in quadrant 3. Then let's say this is angle alpha. Let's say that's angle alpha. Then angle alpha hat will be this one here. Okay. Now, of course, if the angle, the theta is in quadrant 1, if the theta is in quadrant 1, let me call beta instead here. If the beta is in quadrant 1, then beta must be equals to the reference angle itself. Okay. Now, however, in general, you will see reference angle has to be an acute angle. That's one. Okay, and it will be the angle from that side, from that terminal side to x-axis. It doesn't have to be positive x-axis. It may be negative x-axis. It's fine. Okay, let me do the last one. Suppose I have a terminal angle, angle in quadrant 4. Okay, let's call this angle gamma. I don't know how to do it. Let me make it this way. Let's call this angle gamma. Let's call this angle gamma. Now then the angle, the reference angle is the one here. Is it okay? Now you see the following. Suppose beta is in quadrant 1. Suppose the angle is in quadrant 1. Then the reference angle will be just the same to that angle. It's already in quadrant 1. It's already acute. Right? Now, suppose the angle is in quadrant 2. You see from that picture? If the angle is in quadrant 2, okay, if the angle is in quadrant 2, then the reference angle will be 180 degrees minus that angle. Now that's if we do the degree version. The radian version will be, if we do it in radian, then it will be pi minus theta. Okay, that's for the radian version. But let's stick with the degree version for now. You can adjust that later. Now, what happened if the angle is in quadrant 3? If the angle is in quadrant 3, like the one we have here, that's angle alpha. Right? Alpha. And you see this alpha is more than 180 degrees, right? More than 180 degrees in quadrant 3. So the reference angle must be that angle minus 180 degrees. Now, try not to memorize this, this formula that I gave you here, but look at that from the picture. See that from the picture. Okay, and then last one, if the angle is in quadrant 4, then the reference angle will be the theta hat, gamma hat here, will be 360 degrees minus gamma. Okay. But again, that's just formula. We will see that again later on. Okay, you don't need to memorize it right now. What I need you to have is understand that for each angle in standard position, it has reference angle associated to it. Now, let me give you the purpose of us learning reference angle. let's go back to that unit circle. Let me just copy that somewhere. I do it. Let's see a unit circle. Actually, it doesn't have to be unit circle, but you can see that from unit circle point of view. Now, I want you to realize the following. Suppose that I have an angle here. Suppose I have an angle here. Okay, say this is theta. Now, this will be the theta head, right? That will be the theta head. Let me copy paste that theta head, but I put that in quadrant 1. Put that theta head in quadrant 1. This is theta head. Okay, now notice that if the theta is in quadrant 2, then they must have the same y, but opposite x. Okay, so let's say the coordinate here is, of course, cosine theta sine theta. Okay, and the coordinate here is cosine theta head sine theta head. Okay, now then notice that the y will be the same. Okay, so from the coordinate here and coordinate here, they have the same y, but the x is opposite. Okay, imagine if you reflect this coordinate here with respect to y-axis, then you get that coordinate, right? Okay, so they will have the same y, but opposite x. In fact, if I go full blown, let me do it this way. Now notice that all these coordinates here, the coordinates we have here, the coordinate we have here, all corresponds to an angle. All corresponds to an angle whose reference angle is theta head. Okay, so if the xy component in quadrant 1 is cosine theta head sine theta head, then the coordinate here must be let's say this is cosine theta head sine theta head, and notice that all these coordinates here, this coordinate here, this coordinate here, this coordinate here, okay, all these, notice that all of them has the same reference angle. Okay, now suppose the coordinate in quadrant 1 is x comma y. Can you tell me what's the coordinate in quadrant 2? Well, the x will be opposite, can you see? Right? But it must have the same y, right? Instead of calling it x and y, let's change that. Let's call that, for example, p comma q. Let's call this coordinate p comma q in quadrant 1. Then what will the coordinate be in quadrant 2? With the same reference angle. It will be the opposite x, but the same y. Right? How about the coordinate here in quadrant 3? The coordinate corresponds to an angle whose reference angle is theta hat. Then the coordinate must be, you see, the x are opposite, right? The y also opposite. Okay, so this will be negative p, negative q. And this guy here will be the same x, but opposite y. Okay, now that's the idea. If you don't get it now, don't worry. I will be a lot more explicit now. We go back to this picture. We go back to this picture. Notice that this angle here is 120 degrees, right? So in quadrant 2, those special angles will be 120 degrees, 135 degrees, and 150 degrees. Okay, now notice that, for example, this 120 degrees has the same reference angle to 60 degrees. Right? The angle here is 60 degrees. This is the reference angle, 60 degrees. Okay? But the coordinate correspond to 60 degrees in quadrant 1 is this, 1/2, comma, radical 3. Okay? So you will see, I will connect this coordinate here with this coordinate here. They have the same reference angle anyway. So what is the coordinate here? That will be opposite x, the same y. Okay, now likewise here, then opposite x, same y. I have to connect this guy with this guy. Okay, because 135 degrees has the same reference angle to 45 degrees. Okay, so the numbers in the coordinate must be the same. The numbers must be the same. And if they differ, it will differ on the plus minus sign only. Okay. Now, using the same idea for 150 degrees, then the coordinate here will be negative radical 3 over 2, comma 1/2. Okay. I go on further. In quadrant 3, the special angles are, well, from 180 plus 30 degrees, that's 210, plus 45 degrees, 225 degrees, plus 60 degrees, that's 240 degrees. And then the coordinates, for example, to help us visualize that, the coordinates here correspond to the coordinates there. You see that? Okay. Therefore, the coordinates here must have something to do with the coordinates there. The x is exactly the opposite. The y also the opposite. Right? The x is opposite in quadrant 3. The y also opposite in quadrant 3. The x is opposite is in quadrant 3. The y is opposite in quadrant 3. Okay, so even though I was working on problems here, okay, but my eyes actually looking at the coordinates here. You see? Now, let's use the same idea for quadrant 4. In quadrant 4, the reference angles, the angles are, the one here is correspond to 30 degrees. So this is 330 degrees, right? You see, what is the angle such that the reference angle in quadrant 4 is, what is the angle in quadrant 4 such that the reference angle is 30 degrees? Well, then it must be 330 degrees. Okay. Now, let's try. What is the angle here? Corresponds to this one here. What's the angle here? That will be 315. And how about this one here?
300.
300 degrees, that's right. Okay, now you should be able to fill up the radian measure yourself later on. Okay, now the reason I give you that blank worksheet later on, I want you to try to print it out and write all these informations in. Okay, it's not about memorizing the informations, but memorize how you get those numbers. Okay, memorize how you get those numbers. It's about the method. Okay, memorize how you get those numbers, and therefore once you get the angles, and you will also be able to find the value, the x and y coordinates on the unit circle corresponds to those angles. Okay, and that will give you the values of the trig values of for that angles. Like for example, this 315 degrees. This 315 degrees must have something to do with the reference angle 45 degrees, right? Okay. Now then you kind of pull the line from there. Oh, okay, what will be the same? Well, the number must have something to do with radical 2 over 2 and radical 2 over 2. Must have something to do with that, right? Okay, but how about the positive negative? Is the x positive? Well, it's in quadrant 4, right? So the x must be positive. How about the y? The y must be negative. How about the number? The number is the same. The number is the same for the y's, okay? But the sign, the plus minus, it will be minus here because it's in quadrant 4. Okay, that's how we do it. So the coordinate here is negative radical 2 over 2. I'm sorry, positive radical 2 over 2 for the x component. For the y component is negative radical 2 over. How about for 330 degrees? that will be radical 3 over 2. The y will be the opposite, negative 1/2. Okay, and then for 300 degrees, you imagine 60 degrees up here. Okay, imagine 60 degrees up there. Then for 300 degrees, the coordinate will be positive 1/2 for the x component and negative radical 3 over 2 for the y component. I try not to draw too much unnecessary graph here and just put in the one that you really need to see. A lot of information in this one picture, I know. But if you try to memorize them, there will be too much things to memorize. Okay, there will be too much things to memorize. Instead of memorizing this picture only, I mean, you have to memorize the unit circle, okay, and whatever you have on the first quadrant. But then once you realize the reference angle idea together with the plus minus in the second, third, and fourth quadrant, by the way we learned it last time, then we will be able to do this magic. Take a look there. Now notice that all the coordinates correspond to this rectangle here. All the coordinates correspond to this rectangle here must have the same or opposite x, the same or opposite y's. Okay, the x are all positive or negative 1/2. The y all radical 3 over 2 with plus minus. Okay, and all the angles correspond to these vertices. All the angles correspond to the vertices of these coordinates. All of them have reference angle 60 degrees. Okay, basically we can say this: if those angles have the same reference angles, then the value of sine and cosine must be the same. The value for the sines for those angles must be the same or opposite. The value for the y's will be the same or opposite. Okay, now I can do more. Instead of this one, let's see this guy. Take a look. Notice that everything in this rectangle here, all the coordinates on this rectangle here must have the same or opposite axis and the same or opposite y's. And all the angles have the same reference angle. Okay, so one thing we will do later on is, I think in the next section, is once we know an angle, we can find the reference angle, and from there we will be able to find the value. Okay, just for fun. Suppose for example, I ask you, for example, we want to compute what is the value of sine 150 degrees. Okay, then we ask first, what is the reference angle? If the theta is 150 degrees, that is in quadrant 2, by the way. Okay, then what is the reference angle? Oh, the reference angle is 30 degrees. So the value of sine 150 degrees must be the same to the value for sine 30 degrees, maybe plus minus, right? Okay, then we ask ourselves, sine in quadrant 2 is positive or negative? Or sine in quadrant 2 is positive? Okay. Then what is sine 30 degrees? From my memorization, that's 1/2. Now, how about cosine 150 degrees? Cosine 150 degrees. Cosine is in 150 is in quadrant 2. Cosine is negative. The reference angle is 30 degrees. Bang! This is negative radical 3 over 2. So you see, whatever angle you give me, if it is a special angle, I will bring it to quadrant 1 first. I look at the reference angle first, okay? And then I see the quadrant to tell me if it is positive or negative. Once it is in quadrant 1, then I can kill it fast. How about, for example, tangent 240 degrees? Well, 240 degrees is in quadrant 3. So the tangent is negative there. Okay, but what is the reference angle? The reference angle is 60 degrees. Okay, you can try to imagine that 240 degrees is quadrant 3, right? Okay, now notice that the reference angle is here. That's the reference angle. Well, it's basically the original theta, but you subtract 180 degrees. Right? Okay, so we get that reference angle 60 degrees. So tangent 240 degrees equals to negative tangent 60 degrees. And that would be negative. Oh, what is tangent 60 degrees? It's radical 3. There. Okay. Now from this picture also, we actually see something important. From this picture also, we see something important. From this idea, we also see something important. How do we tackle negative angle? Let me start again with the circle. And we can call this unit circle if you like. Okay, just call this unit circle. Normally describe. Now, suppose I have a negative angle like this. Suppose I have let's say this is negative theta. Notice that this negative theta has the same reference angle to this one. the same reference angle to this. Okay, now we know that the coordinate here will be, according to our unit circle approach, the coordinate here will be cosine negative theta, sine negative theta. That must be the coordinate. Okay, but at the same time, notice that the coordinate here must have the same x value to the coordinate here. The coordinate here is cosine theta, sine theta. Okay, it must have the same x values, but the y values are opposite. So from here we see they have the same x, opposite y's. Okay, so Thomas, what it means? It means the following. Cosine of negative theta, if we go opposite direction, that will be the same to cosine theta. However, sine of negative theta, the y component of negative theta, the y component of the coordinate correspond to negative theta on the unit circle, is the opposite of the y component if you change the negative theta becomes theta. Okay. By the way, this suddenly leads us to another group of basic identities. So let me add to our basic identity, basic identity 4. The first one is cosine negative theta equals to cosine theta. Second, sine negative theta is negative sine theta. And you will see consequently the tangent will be negative. Tangent negative theta is negative tangent theta. What's the proof? I give you the picture proof, and I did it just now. This is the picture proof. Okay, that's the picture proof. Now, actually, in short, we can say that cosine is an even function. Right? Well, how do we know a function is even function? Well, the function of negative x equals to fx. Right? That's what we see there. Okay. While with a similar idea, we can say that sine is an odd function. Because of this, sine of negative angle equals to negative of sine of that angle. And using the definition from basic identity 1, then tangent negative theta is negative tangent theta. The proof is pretty much like this. Tangent negative theta equals to sine negative theta over cosine negative theta. That's negative sine theta over cosine theta. That's negative tangent theta. That's the proof. Okay, that's the sketch of the proof. Okay, things you have to memorize is actually that basic identity 4, which in words is to say that cosine is an even function, sine is an odd function. Okay. Now, suppose, for example, I want to do some problem from our book. Suppose, for example, I ask myself, okay, Thomas, what is, for example, cosine negative 3 pi over 4? That's in radian, by the way. And then I say, oh, you know what? Using basic identity for the first one, the cosine is an even function. So cosine negative is cosine positive. Okay, and then next, I realize, oh, you know what? 3 pi over 4 is in quadrant 2. Okay, 3 pi over 4 is in quadrant 2. In quadrant 2, cosine will be negative. Okay, and the reference angle is pi over 4. Okay, so from here, I get negative cosine pi over 4. Now, what is cosine pi over 4? Radical 2 of. Okay. Now, let's take a little break. I'm pretty much done with 5.3. I'm pretty much done with 5.3. What I'm going to do next is to extend the idea. After the break, I will extend the idea to 5.4. We already have the foundation there. Okay, we already have the foundation from what we have in this lecture. Okay, and then from there we will learn to do identity proving. Okay, but let's take a break first. Right now is 10:40. We come back at 10:50. I totally forgot to record. Okay, that's for 5.4. To get the reference angle. Sorry not to record that earlier. I'm saying this for those people who will watch this video later on instead of because they could not attend the lecture. Okay, now let's go on. Number 8. I think if you look at the pictures, for those who didn't see my lecture directly, or you skip to this part right away, try to imagine what's the position of that angle in the coordinate system. Okay, and categorize that in quadrant 1 or 2 or 3 or 4, and then see from the picture also how to get the reference angle, okay, which is the acute angle from the terminal side to the closest x-axis. Okay, we will see that again in future questions like number 8. Number 8a. Number 8a. Compute the value of sine 210 degrees. Now then, we ask ourselves 210 degrees is in which quadrant? Then you draw it, right? This is 180 degrees. This is 270 degrees. Then 210 must be in quadrant 3, right? This is 210. Between 180 to 270. That's quadrant 3. And how about the reference angle? The reference angle must be this part here. Okay, which is basically the original angle subtracted by 180 degrees. Okay, so the reference angle is 210 degrees minus 180 degrees. That's 30 degrees. Now then we look back to our board here. Sine in quadrant 3 is positive or negative? from Monday we learned sine in quadrant 3 is negative. Okay. Then what is the sine of the reference angle? The reference angle is 30 degrees. So this will be negative. What is sine 30 degrees? That's right, that's 1/2. How about part B? Part B, what is sine negative 315 degrees? Oh, Thomas, I don't know what negative 315 degrees, but if I want to make it positive, then I will add 360 degrees, right? If I add 360 degrees, I get 45 degrees. Okay, so sine negative 315 degrees is the same to sine 45 degrees because these two angles are coterminal. Okay, then sine negative 315 degrees must be radical 2/2. Now, there's another way to do this a bit longer. Don't worry, it's a bit longer, but we may learn even more. We can see it this way. Oh, that's negative angle, right? The sine of negative is according to B for 2, the negative angle. Sine is odd function, so sine negative is negative sine. Okay, but then this 315 degrees is in which quadrant? And I look at the picture here. Oh, 315 degrees is between 270 to 360. It is in quadrant 4. It is in quadrant 4. Okay, and the reference angle is, as you can see here, the reference angle is 45 degrees. Okay, so in quadrant 4, sine is negative of reference angle 45 degrees. The negative cancels the negative here. Sine 45 degrees is radical 2/2. That's just another way to do that. Okay, that's for sine in degrees. Now let's try to do another function, and also at the same time we will deal with radian. Let's say, for example, number 10a, cosine 5 pi over 4.
Sorry, Professor, quick question.
Uh-huh.
On the last example, it looks like sine should be negative, right? Or
Sine in quadrant 4 is negative, that's right.
yeah, but the answer here, it says a radical 2/2. Why is that positive?
Okay, what happened is, if you look at sine 315 only, that gives you negative value. Right? That's sine 315. But sine negative 315, sine negative 315, I bring the negative out first.
Oh, I
Sine
see.
negative. So you see that there are two negatives cancels here.
Yeah. Okay, I
Right?
didn't see
Okay.
that. Thank you. Yeah.
Now, cosine 5 pi over 4. Let's see, 5 pi over 4 is in which quadrant? Five pi over 4 is definitely more than pi. Okay, but less than 3 pi over 2. Right, so it is in quadrant 3. Okay, and the reference angle is, it is in quadrant 3. So the reference angle is 5 pi over 4 minus pi. That's pi over 4. Now, because it is in quadrant 3, the cosine is negative. So it will be negative cosine of the reference angle. So that will be negative radical 2 over. Okay. Let's see part B, number 10B. Let me do it below. 10B. Cosine of negative 11 pi over 6. Now there are two ways to do this. Usually I myself, when I see negative angle and the angle is big, I tend to add 2 pi or 360 degrees. Basically, I try to make it positive first. So negative 11 pi over 6, that's coterminal to negative 11 pi over 6 plus 2 pi. Now that will be negative 11 pi over 6 plus 12 pi over 6. That's pi over 6. Okay, so cosine of negative 11 pi over 6 is, because it's coterminal to pi over 6, then it must have the same value. Now, to our luck, it happens that the coterminal located in quadrant 1. So we can compute that right away. What is cosine pi over 6? You may change that to degree first, right? If you don't get used to it, but I hope the further we go, you get used to it even faster. Okay, this will be cosine 30 degrees. That is radical 3 over 2. Okay, now the other method is the alternatively. You use cosine as an even function. Cosine is an even function, so cosine negative equals to cosine positive. That's according to B for 1. Okay, B for 1 says cosine negative equals to cosine positive. Okay, and then next, we need to categorize this 11 pi over 6 is located in which quadrant. Now, it's definitely more than 1.5 pi, but it is less than 2 pi. Okay, so from there we see, oh, it is actually in quadrant 4. Okay, and the reference angle is 2 pi minus 11 pi over 6. That's pi over 6. Cosine in quadrant 4 is positive. We usually don't write this positive down. Cosine of the reference angle. That's how we get that radical 3 over. Furthermore, number 12A, tangent 330 degrees. Okay, I will still do that, but I would like your cooperation with me. I want you to do it together with me. Now, the first thing, 330 degrees is in which quadrant? In 10 seconds.
Quadrant 4.
That's quadrant 4. See, you can do it even faster. Okay, now how about the reference angle? 10 seconds. 30 degrees. Now then you go back here. Okay, because it's in quadrant 4, tangent is positive or negative?
Negative.
Negative. What is the reference angle? 30 degrees, right?
Yes.
Now then you ask yourself again, what is tangent 30 degrees? This is supposed to be 5 seconds.
Root 3.
Root 3 over 3.
Root 3 over 3.
Yeah, okay? Yeah, let's do again. That's number 12A. How about 12B? 12B, tangent of negative 225 degrees. Okay. How to deal with negative angles? You know what? Let me add first the coterminal 225 degrees. That's coterminal with 225 plus 360 degrees. That's equals to 5 seconds.
135.
135 degrees. Okay, so that tangent negative that is coterminal to tangent 135. Next, 135 degrees is in which quadrant? 10 seconds.
2.
Quadrant 2. Okay, and then the reference angle is 10 seconds.
15.
45.
45.
45. 180 degrees minus 135 degrees. That's 45 degrees. So in quadrant 2, tangent is positive or negative?
Positive. Oh, sorry, negative.
Negative. The
Negative
reference angle is 45 degrees, right? 45 degrees. And the final answer is
-1.
-1. I like that I can do this kind of coloring, which I cannot do in class, you know. Yeah, but then you see that what we do. So what happened is this, you notice that in this one step from here to here, we actually do two things, right? In this one step from here to here, we actually do two things. Okay, in that one step. Okay, now that's number 12A. How about number 14?
Okay.
Number 14. 14A. We have cotangent, cotangent 3 pi over 4. You know what? I don't know how to deal with cotangent. Let me make it 1 over tangent first. Is it okay? 1 over tangent of 3 pi over 4. Whew. Okay, at least I can go that far. That will be 1 over, 3 pi over 4 is in which quadrant? 10 seconds.
Second.
Second quadrant. It's less than pi, but more than pi over 2, right? Okay, and the reference angle is?
Pi over 4.
Pi over 4, that's right. Eventually you will get faster. It's just about you need to get used to it. Okay, but eventually you will get faster. I'll give you 10 seconds. That's actually, if you can do it in less than 10 seconds, you're good. Now then, well, tangent in quadrant 2 is positive or negative?
Negative.
Negative. And then the reference angle is pi over 4. So this is pi over 4 here. Okay, then what is tangent pi over 4?
1.
So this is 1 over -1, right? Which is -1. Okay. Yeah, of course you can say, Thomas, can I just use calculator? You know what? If you don't practice, then calculator always faster. But if you practice on those special angles, without calculator will be faster. Okay. You can also do it this way though. For this kind of question here, let me use another color. Alternate way to look at that. I deal with that cotangent right away, 3 pi over 4. Okay, and then I say, oh, 3 pi over 4 is quadrant 2. Tangent is negative, so negative cotangent also negative. Boom. Reference angle, pi over 4. Boom. Okay, then I deal with that. This is 1 over tangent pi over 4. Like that. That's negative 1. Boom, faster. Okay, so there are many ways to do that. In your test, I need you to show me the work though. Okay, little step by little step from here to there. Okay, now that's for number 14a. Let's take a look on 14b. Oh, that's harder. 14b, we have cotangent of negative 2 pi over 3. Okay, let me give you 2 minutes to do this.
I got 0.93160.
3160. That's right. Okay, let me give you 3 minutes to do number 24a and b. That's cosecant 43 degrees 40 seconds. And the other one is secant 0.26. Okay, let me give you 3 minutes for this. Okay, so in degree decimal, this will be 43.66667 degrees. Is it right?
Yes.
Yeah, 40 minutes is 2/3 degrees. Okay, and then this will be 1 over sine of 43.66667 degrees. And then I use my calculator. Yes, you can do that. You can do 1 over sine 43.66667.
-3. Oh, I'm so wrong mode. Sorry, I was in the wrong mode.
Got you.
Yeah.
So 1 over sine 43.66667 is 1 plus 44831. Yeah, always check your mode first. Always check your mode. Anyway, before I go on, let me show you something. Let me show you something. You know, I have my calculator on my computer, the TI-84 emulator. Okay, now this calculator is in degree mode. This calculator is in degree mode. However, if you look at me here, I have another calculator at my hand. I have another calculator here. Now this calculator will be in radian. Okay, so here's the thing. Okay, I have a student did this before. These students happen to have one calculator for himself, and then during the test, he actually borrowed another calculator. But on the top of the calculator, he wrote kind of like he wrote, this is radian, and another calculator is degree calculator. You know, okay? Because if you don't write it there, you forget what mode you're working on. You see what I mean? Okay? I mean, I learned this from a student too. Okay? I learned this from a student too. You know, so if you happen to have extra calculator, you may consider using those two calculators though. Just make sure that you write, clearly on that calculator, this is calculator for degree, the other calculator is for radian, like that. Okay? Yeah, that's something I think you can try to benefit from. Now, next, how about secant 0.26. Oh, this is 1 over cosine 0.26. Okay, now make sure it is in radian mode. 1 over cosine 0.26. I get 1.03478. Okay, that's for number 22. Now, still on calculator, still on calculator. It is still on calculator. What happened if I need to find the angle instead? Now, suppose, for example, number 26. The assumption is the theta is in the first quadrant. Okay, or sometimes we say theta is an acute angle, just to make sure that it is in quadrant 1. Okay, now number 26. Number 26, if sine theta equals to 0.6612, then what theta be? Okay, now in future, I think it's chapter 6, maybe chapter 7, I will teach you what happens if theta is not in quadrant 1. But we deal with quadrant 1 case first. Okay, we deal with quadrant 1 case first. If sine theta equals to 0.6612, then theta will be sine inverse of 0.6612. Okay, and you can answer this in radian, you can answer this in degrees. I will do it in degree right now. I will do it in degrees. Now, how do I punch this? Let's look at my calculator. I know it's different from your calculator. But you can adjust. Basically, I need to first make it into degree. Okay. You can make it into radian also, but just make sure that if you do it in radian, you don't put degree signs later. Okay. Now, so what is sine inverse of 0.6612? The way I get sine inverse, usually on your calculator, sine inverse is the second of sine. Second of sine. I hope you see that. Use your calculator. Confirm. And then I put 0.6612. And then I press enter. I get 41.39146. That's 41.39146. That's 41.39146. Is this in degree or radian?
Degree.
In degrees, then I put degree sign. Okay, that's for number 26. Now you try number 30.
Professor, quick question on number 26. Would you be able to enter a 1 divided by sine?
Oh, no, you can't. You can't. Well, because we know that we know from the past that f inverse x is not 1 over. It's not 1 over. Remember that?
Mm-hmm.
Okay,
No.
Good point though. Good point. So this is an inverse function, not the reciprocal of a function. No. 1 over sine is called cosecant.
Mm-hmm.
Right? Okay, sine inverse is to undo that sine function. Okay, yeah, good that you remind me to actually mention that. Okay, so number 30, tangent theta is 4.91. Tangent theta is 4.91. So if theta is in quadrant 1, then theta will be tangent inverse of 4.91. I wonder what's that. What's that?
78.488.
78.48824. Because it is in degree, I use degree sign.
Is there a number of significant digits you want us to do, or?
In my class, every time you do rounding, round to 5 decimal places.
Okay.
Yeah.
Hey, Thomas.
Yes.
The second part of the question for the exercises 25 through 36, it says find the nearest angle, and that's part A, and then and part B is like to the nearest second.
That's actually to the nearest minute.
I'm sorry, to the nearest minute.
Okay, let's do that. Let's do that. So the follow-up question from here is let's continue from number 26. What will that be in DMS? Okay, now instead of making it only into the nearest 1 minute, I will make it into the nearest 1 second. Okay, I hope that way then you will see the consistency. Now notice that this is actually equals to 41 degrees plus 0.39146 degrees, right? Now I will break this up. I will rewrite this into minutes. 1 degree is how many minutes?
60.
So 0.39146 multiplied by 60 degrees give me 23.4876 minutes. Okay, so from here to here, multiply by 60 minutes. Okay, now I break it up even further. This is 41 degrees, 23 minutes, plus 0.4876 minutes. Okay, now change this to seconds. 1 minute is 60 seconds. So 0.4876 multiplied by 60, I get 29.256 seconds. So if I round it to the nearest seconds, that will be 41 degrees, 23 minutes, 29 seconds. Okay, I hope you see the pattern. Now, let's try this number 30 in DMS. This is 78 degrees plus 0.48824 degrees. Now, multiply this decimal part by 60.
29.2944.
Good. So that's 78 degrees plus 29.2944 minutes. Now that's the same to 78 degrees, 29 minutes plus 0.2944 minutes. Now, then change it to seconds.
17.664.
17.664. So if I round it to the nearest seconds, it will be 78 degrees, 29 minutes, 17 seconds. Okay. By the way, if you happen to have a privilege of getting an airplane, especially international flight, like you go to another country, international flight, usually when your plane already get to the gate, right? Right at the nose of that plane, they usually give the position of the plane on Earth, and it's usually expressed in DMS. It's usually expressed in DMS. Okay, so in my, as far as I know, that's actually the only time I see people use DMS in life. I hope now you realize why I don't really emphasize this. Okay. At the same time, it's not too hard to do though. So even if I ask you this type of question, consider that the bonus question. Okay. Now that's for tangent. Now, what if we have a question that inverse function is not on our calculator? Let's say number 32. Cotangent theta equals to 0.361. Now we don't have cotangent inverse. So before I do cotangent inverse, which I don't have on my calculator, make it into tangent first. Now cotangent and tangent are reciprocal, right? Okay, so when I write tangent theta, then tangent theta will be 1 over 0.361. Agreed? Now, and then theta will therefore tangent inverse of 1 over 0.361. Now, then you use your calculator. Okay, tangent inverse of 1 over 361. I get, what do you get, by the way?
I got 70.15042 years.
50. Okay. I think that's for this section. I would like you to, the suggested homework, I would like you to do 5.4, number 1 to number 37. Number 1 to number 37. Of course, just do the odd ones. Okay, I still owe you things from 5.2, 5.3, 5.4. I still owe you proving identities. Okay, now it happens that on 6.1, in the next section 6.1, we have that proving identities. So I don't need to do it right away right now. However, I would like you to watch my lecture video from my other class. And of course, the part of that you will see also proving identity. But the one that we need to do in the next section 5.5, instead of reading, I want you to watch lecture video. At my West LA College Math 241 Chapter 4. Okay, now then after that you will see proving identities, I think in 5.1. Okay, the lecture video is a bit long. Of course, I will still go over that, whatever I did on that lecture video. I will do that on Monday, okay? But I will do it a lot faster, okay? Math 241 at West LA College is just for trigonometry. So I basically go over that a lot slower. Now, where to find that? where to find that lecture video. I hope you, if you remember my channel on YouTube. Okay, let's say you go to your browser, you go to YouTube. Are you with me on my browser right now, YouTube?
Yes.
Okay, now then you type Arduino. Now then go to the playlist. Then look for Math 241. This is Math 241. Go to the full playlist. Now then, the graphing part will be on 4.1. So I strongly suggest you, if possible, especially for next week, I want you to watch this, the first, how many? The first 5 lecture videos. It will be so very long, I know. It will be very long. But at the same time, those are things that I believe you can understand yourself. Okay, let me play this 3.5, 4.1. Now this 3.5 is a lecture video for velocities. In our textbook, velocities is part of 5.1. Okay, now then if you go on further, let me go on further. This is 3.5, still 3.5 for them. Now then I go on to 4.1, basic trig functions. So especially this 4.1, I want you to take a look on how I do it. I basically graph the graph of sine, and then later on I graph the graph of cosine. Okay, I wonder why no sound there. There's supposed to be some sound. Well, anyway, now then and then in 4.2, you will see we do sine and cosine again, but with a lot of reflection, amplitude, so on and so forth. Okay, and then on 4.6 later on 4.6, you will learn inverse function, inverse trig function. Now 5.1, you will learn to show identity. Okay, you will learn to show identity. Now that's basically what I need you to study for next week. Okay, so next week, according to my plan, I will finish 5.5 and a quick fast way to do 5.6, and then again do 5.7 and go to 6.1. That's what I plan to do next week. Okay, so please to help you catching up, I rather you have your time watch the lecture video first at home, and then when we do it in class, we can do it faster. That way then we can catch up and finish the material. Okay, now from now on, you can tag, or you can tag that Math 241. The flow of the lectures in the next 2 or 3 weeks will be very similar to what you see there with the flow there. Okay, that's for today. See you then on Monday. Hold on.